All right, in order to apply more things with Laplace transforms, we obviously really like the shortcuts. So there is one way that we can write piecewise functions in a way that we can apply a new shortcut. So we call this the unit step function. And all we're going to do in this video is just look at what this function does. So basically, it is something that turns on part of a function and then turns part of that function off, kind of like when we have a domain restriction on a piecewise function. And so we use this unit step function in this following way. So we say that it is 0 up until that point A, and it is 1 when the time frame is greater than A. We're not worried about any negative times here. Okay, and basically what happens is when we multiply by 0, then we get 0, so that function's not going to be in existence. And we multiply by 1, then that function gets used. So I already said it's not on the negative axis, okay? And oh, here's the step function right there. There's the graph. So when this function is applied, we multiply the function by this notation here. And it is going to say, like, turn on the graph when t is greater than a. So if we look at this function, this line, and I'm only going to do for t greater than 0, it would look like this. But I don't want this function to be applied from 0 to 1. I just want it to be applied after t equals 1. Then I can say multiply f of t by this function, and that says that this is 0 for 0 less than or equal to t is less than 1, and this function for t greater than or equal to 1. And so my function is now this line here, but then 0 before that, before t equals 1, if you will. And you can see, oh, look, there's the graph right there. All right, so let's write this for my function that I have here. So let's graph it first. I know that that's not what the directions say to do in order, but that's what I would like for us to do. So f of t is 20t from 0 to 5, and then 0 forever after that. So what I will say if I want to write this in terms of the unit step function is I'm going to say f of t equals this function forever and ever and ever and ever and ever. But then I might want to take something away so that when t is greater than 5, I can then apply this piece right here. Well, the only way I'm going to be able to do that is if the opposite of addition is subtraction, is if I subtract out whatever that value is, and then say, like, this part only applies after 5. This applies between up until 5. And that's how the step function works.